In this video, we're going to learn how to solve a utility maximization problem when we have a perfect complements utility function. Amina has $100 to spend on creating the perfect cozy corner with blankets and pillows. Her utility function is given by the following. Utility is the minimum of 3x and y, where x represents the number of blankets and y represents the number of pillows. The price of a blanket is $20 and the price of a pillow is $10. Our goal is to determine Amina's optimal choice of blankets and pillows. What do we need to know in order to solve this question? We need to know the utility function, the price of each good, as well as the consumer's income. How are we going to solve this utility maximization problem? A little differently from your typical problem because we're not going to have a tangency condition. And the reason why we don't have a tangency condition is the indifference curves of the perfect complements utility function don't have curvature to them, they're right angles, and it's not possible for a right angle to be tangent to a downward sloping budget constraint. As a result, in place of the tangency condition, we have what's called the no waste condition. And the no waste condition guarantees that we aren't purchasing any pillows or blankets that aren't adding to our utility. And the no waste condition is simply to take the two arguments of the min function here and set them equal to each other. It essentially forces us to be at the point of the right angle indifference curve. Along with our no waste condition, Amina still has to live within our budget, so we have our budget constraint, which is in the standard form. The price of x times x plus the price of y times y is equal to income. Let's solve this question. Here's what we know, the utility function, the prices of the two goods, and the income. And we know we're going to find Amina's optimal choice of blankets and pillows. So we have two conditions that we have to meet, the no waste condition and the budget constraint. So let's fill in the information for these two conditions. So the no waste condition is just that the two arguments inside of the minimization function here equal each other. So we have 3x equals y. We'll call that equation 1. The budget constraint is the price of x times x plus the price of y times y equals income. We'll call that equation 2. Once we write down the no waste condition and the budget constraint, we can start solving the resulting system of linear equations and unknowns. I'm going to substitute 1 into 2. So in place of y, I'm going to put that y is equal to 3x. So I have 20x plus 10 times 3x equals 100. 20x plus 30x is 50x equals 100. So it must be that x is equal to 2. And we can call that equation 3. At this point, we're really basically done. We have used the no waste condition and the budget constraint to determine that the optimal amount of x is 2. All that's left is to take x equals 2 and plug it back into the no waste condition, equation 1, to solve for y. So y is equal to 3 times 2, which tells us that y is equal to 6. So we're done. In fact, if you ever encounter a perfect complements utility function on a homework or an exam, you'll actually find that the mathematical process tends to be simpler than a more traditional utility function because no calculus is required. So what's our final solution here? Amina's optimal choice is to purchase 2 blankets and 6 pillows for her cozy corner.